Welcome to another lesson of Math 0420, Introductory Algebra. In this lesson, we will be discussing section 1.2, Fractions in Algebra. In this section, we will convert between mixed numbers and improper fractions, write the prime factorization of a composite number, reduce or simplify fractions, multiply fractions, divide fractions, add and subtract fractions with identical denominators, add and subtract fractions with unlike denominators, and solve problems involving fractions in algebra. Let's start with some definitions. Okay, our first definition. In a fraction, the number above the fraction bar is called the numerator, and the number below the fraction bar is called the denominator. So we have numerator and denominator. The numerator is the top number in the fraction. The denominator is the bottom number. Next, the natural numbers are the numbers we use for counting. In other words, 1, 2, 3, 4, 5, and so on. Okay? That's the natural numbers. Our next definition is of a mixed number. A mixed number consists of the sum of a natural number and a fraction. Examples of these would be 3 4/5, which is 3 plus 4/5. Okay, and then our last definition for us to get started here in this section is an improper fraction. An improper fraction is a fraction whose numerator is greater than its denominator. Again, that's improper fraction. Previous one was mixed number. Examples of improper fractions: 5/4, 10/9, 36/17. All of those have numerators that are greater than the denominators. Let's talk about the steps for converting from a mixed number to an improper fraction. Okay, converting from a mixed number to an improper fraction. Step 1. We want to multiply the denominator, the fraction, by the natural number, and the numerator to this product. And then step 2 is to place the result from step 1 over the denominator of the original mixed number. Let's try an example. Example 1. We want to convert 2 5/8 to an improper fraction. So our first step is to multiply the whole number, the natural number, by the denominator, the fraction. So we get 2 times 8, which is 16. And then we add the 16 to our numerator, which is 5. 16 plus 5 gives us 21. And our second step tells us that we take the result from step 1, which is 21, and we divide it by our original denominator from the problem, which was 8. So we converted 2 5/8 to an improper fraction, which is 21 over 8. Let's now talk about the steps for converting from an improper fraction to a mixed number. So convert an improper fraction to a mixed number. Okay, our first step is to divide the denominator into the numerator. Next, we need to write the mixed number using the following form. The quotient is our natural number, and then the fraction part is the remainder from the division over the original denominator. Let's try an example. Example 2. We want to convert 5/3 to a mixed number. So the first thing we do is we're going to do division. So we have 5 divided by 3. We'll do this sort of long division form. 3 will go into 5 one time. 3 times 1 is 3. 5 minus 3 is 2. So our quotient is 1. And our remainder is 2. So how do we write that as a mixed number? Well, we write it as the quotient and then the remainder over the original denominator, which was 3. So our answer is 1 2/3. Let's talk about factors and prime factorizations. Okay, factors and prime factorizations. So just a quick example, factoring 21 as a product of factors. Well, 21 can be rewritten as 7 times 3. You probably know that already. Well, 7 times 3 are called factors. And 21 is the product. Well, there's another set that we could use, and that's 21 is equal to 1 times 21. So there are various ways that we can rewrite the factors of a given number. Well, let's talk about definitions. First definition we need to talk about here is that a natural number is said to be prime if it is greater than 1 and has only itself and 1 as factors. So a number is prime if it is greater than 1 and has only itself and 1 as factors. Well, what about 21? Is 21 prime? Well, we know that 21 has factors of 7 and 3, so it can't be prime. Well, what if a number is not prime? Well, our definition for that is a natural number greater than 1 that is not prime is called a composite number. So 21 would be considered a composite number. Okay, let's move on and do some more. Every composite number can be written as the product of prime numbers. So, one last definition before we do an example. Expressing a composite number as the product of prime numbers is called the prime factorization of that number. Prime factorization of that number. So if we write a composite number as the product of prime numbers, that's called the prime factorization. Let's do an example. Example 3. We want to find the prime factorization of 36. Okay, Okay, so what we want to do is we want to rewrite 36 as the product of prime numbers. Well, let's first break it down into a product that we know. Well, 36 is 6 squared, so it's equal to 6 times 6. Is 6 a prime number? Well, no, 6 is not a prime number. So we can further break that down. 6 is the product of 2 and 3. So we can write both of those as 2 times 3. Well, 2 and 3 are prime numbers. So we can rewrite that as 2 times 2 times 3 times 3. Now, another way you may have seen this is using a factor tree. So you can write 36 at the top, and you find 2 factors that you can rewrite that as. Again, in this case, 6 and 6 is fine. You can choose other numbers if you want. So 6 and 6, neither one of those are prime. You break each one down into 2 and 3, and you circle the ones that are prime. See, that works. Another way you could have used a factor tree, you could say 9 times 4, and that would break down further to 3 times 3 and 2 times 2. And one last factor tree, you could have done 2 and 18. Well, in this first case, 2 is already prime, and then you could do 9 times 2, 2 is already prime, and then 3 times 3. So if you notice, in each case, we still end up with 2 times 2 times 3 times 3. And a prime factorization is unique in this way, in that there's only one prime factorization for a given composite number. Let's now move on and talk about reducing fractions. Okay, reducing fractions. One of the keys for reducing fractions is the fundamental principle of fractions. So if we have the fraction a over b, if that is a fraction and c is a non-zero number, then a times c over b times c is the same thing as a over b. What that really means is we can divide out that common factor in the numerator and the denominator. So if we want to reduce a fraction to the lowest terms, these are the steps we would need to take. Reducing a fraction to lowest terms. So steps. First step we want to do is to write the prime factorization of the numerator and the denominator. And then we want to divide the numerator and denominator by the greatest common factor, which will be the product of all factors common to both. Okay, so that's how we reduce a fraction to lowest terms. Let's do an example. All right, example 4. We want to reduce the fractions to lowest terms. So our first one is 10 over 15. So we want to do the prime factorization of numerator and denominator. So the prime factorization of 10, two factors are 2 and 5. Both of those are prime, and for 15, we have 3 and 5. So what factor do they have in common? Well, they both have a 5 in common. So we can divide both the numerator and the denominator by 5. So that's 2 times 5 over 3 times 5. And those 5s will cancel, and we're left with 2/3. Okay, let's try another. 42 over 24. Prime factorization. Start with 42. We can write that as 6 times 7. 7 is prime, and 6 can be rewritten as 2 times 3. So our prime factorization of 42 is 2 times 3 times 7. And for 24, we have 3 times 8, and 2 times 4, and 2 times 2. Okay, so 2 times 2 times 2 times 3 is 24. So what factors do they have in common? Well, we can rewrite them as the product of their prime factors. So that's 2 times 3 times 7 over 2 times 2 times 2 times 3. We can cancel out a factor of 2 and a factor of 3 from both, and we're left with 7 over 2 times 2, which is 4. So 7 over 4 is our answer there. And we can do one more. What about 9 over 45? Well, we can rewrite the prime factorization of each. I'll skip over the factor tree this time. Prime factorization of 9 is 3 times 3. And the prime factorization of 45 is 3 times 3 times 5. So the 3's will cancel in numerator and denominator. Let's try that again. In both cases, and we're left with just the 5 in the denominator, but we have to have a 1 in the numerator, so our answer is 1/5. So 9 over 45 reduces to 1/5. Okay, let's now move on and talk about multiplying fractions. Multiplying fractions. So if A over B and C over D are fractions, then A over B times C over D is equal to A times C over B times D. In other words, we multiply numerators together and we multiply denominators together. Okay, example 5. We want to multiply and reduce 4 over 11 times 2 over 3. Okay, so we multiply numerators together, 4 times 2 over 11 times 3. Okay, do we have anything any common factors in the numerator and denominator? Well, no, in this case we don't, because both of our factors in the denominator are prime, and neither of those appear in the numerator. So we just multiply numerators together. 4 times 2 is 8, and 11 times 3 is 33. Let's try another. What if we had 3 over 7 times 2/3? Well, we multiply the numerators together. That's 3 times 2 over 7 times 3. We can reduce because we have a common factor of 3. And that gives us 2/7. Okay, that's multiplying fractions. Well, let's now switch over and divide fractions. Okay, dividing fractions. So if A over B and C over D are fractions, and C over D is not equal to 0, then A divided by B divided by C divided by D is the same as A over B times D over C. So there's a little saying that can go along with it, and that is dividing fractions is as easy as pi. Flip the second fraction, then multiply. So you may have heard this similarly as keep, change, flip. Keep, change, flip is the same thing as dividing fractions is as easy as pi. Flip the second fraction and then multiply. So what we want to do now is try a couple of examples of dividing fractions. All right, example number 6. We want to divide and reduce. The first one, 2/3 divided by 7/15. Okay, so we'll keep the first one. We'll change the division to multiplication, and we'll flip the second fraction to be 15 over 7. Then we'll multiply like normal, which is 2 times 15 over 3 times 7. Well, we have a common factor of 3 in the numerator and denominator, so we can divide both sides by 3, or the numerator and denominator by 3. 2 times 15 divided by 3, that's 30 divided by 3, or 10. And we can just cancel the 3 in the denominator, so we're left with 7, so 10 over 7. Okay, let's try another. What if we have 2/3 divided by 3? Well, you say that's not really a fraction, is it? Well, we can write any number, any whole number, as a fraction by dividing it by 1. So that's the same as 2/3 divided by 3 over 1. Well, we can flip the second fraction, so keep, change, and flip. And so we end up with 2 times 1, which is 2, and 3 times 3, which is 9. So our final answer is 2/9. Okay, now that we've dealt with multiplying and dividing fractions, let's talk about adding and subtracting fractions. First, we'll deal with adding and subtracting fractions with the same denominators. So adding and subtracting fractions with identical denominators. So, if we have two fractions, a over b and c over b, if they're fractions, notice right now that they have the same denominator, b, then we have that a over b plus c over b is equal to a plus c over b, and a over b minus c over b is equal to a minus c over b. Okay, let's try an example of adding and subtracting fractions with the same denominator. Okay, perform the indicated operations. For example 7. Part A, we have 2 over 11 plus 3 over 11. Well, since they have the same denominators, we can just add the numerators together. So that's 2 plus 3, which is 5 over 11. Okay, let's try another. 3 and 3/8 minus 1 and 1/8. Now is a good time to remember that it will probably be easier for us to convert these to mixed numbers. So 3 times 8 is 24, plus 3 is 27. So 27 over 8 minus, and then 1 times 8 is 8, plus 1 is 9. So we have the same denominator, 27 minus 9 is 18. So we have 18 over 8. Well, 18 over 8 will reduce. We can divide both sides by 2. So that's 9 over 4. And we can change that back to a mixed number. 9 over 4 is equal to 2 and 1 over 4. Okay. Now that we've talked a little bit about adding and subtracting fractions with the same denominators, we need to talk about adding and subtracting fractions with different denominators. Adding and subtracting fractions with unlike denominators. Example 8. Okay, we want to write 2/3 as an equivalent fraction with a denominator of 21. So a lot of times what we will need to do is make a fraction with a different denominator to get them to be the same, which is called finding a common denominator. So this will help us practice how to change a denominator. So if we want to write 2/3 as something whose denominator is 21, we're going to have to do multiplication. So 3 times what gives us 21? Well, that would be 3 times 7. Well, the only way we can keep an equivalent fraction is for the fraction we multiply by to be equal to 1. Well, that means the numerator and denominator have to be the same. So that would be 7 over 7. So 2 times 7 gives us 14. So 14 over 21 is equivalent to 2/3. Okay, so that helps us change the denominator of a fraction to something that we can use. So let's talk about the steps for adding and subtracting fractions with unlike denominators. Steps for adding and subtracting fractions with unlike denominators. Step 1. we want to rewrite the fractions as equivalent fractions with the least common denominator. And the way we find that is by finding the first multiple where those two denominators are the same. And then once we do that and find equivalent fractions, we can then add or subtract the numerators putting the result over the found common denominator. Let's try an example. Okay, example number 9. We want to perform the indicated operation. For the first one, we have 1/2 plus 3/5. First of all, notice that we don't have the same denominator. So we need to find the least common denominator between 2 and 5. So our multiples of 2 are 2, 4, 6, 8, 10, and 12, and so on. Multiples of 5 are 5, 10, 15, 20, and so on. The first time we get a match is when we have 10. So we want to write both as equivalent fractions with 10 in the denominator. So 2 times what is equal to 10? Well, that's 5, so we need 5 in the numerator. Also, we're multiplying by a clever 1. 1 times 5 is 5. And then to change 3/5, we need to multiply by something to get in tenths. 5 times 2 is 10, so we multiply by 2 over 2. 3 times 2 is 6. So we can take both of these fractions that we've changed to tenths and plug them in up here. And so we get 5/10 plus 6/10. And we can now add the numerators to get 11 over 10. Now we could write that as a mixed number, but we'll leave it as an improper fraction for now. Okay, let's try another. What if we have 3 1/6 minus 1 11/12? Okay, well my first thought is to change to an improper fraction. 3 times 6 is 18 plus 1 is 19, so 19 over 6 minus 1 times 12 is 12. 12 plus 11 is 23 over 12. So what is our common denominator? Well, 6 and 12, they have a common multiple when you get to 12, so we need to change both to 12s. So 19 over 6 times some fraction is equal to something in 12ths. Well, 6 times 2 is equal to 12, so our clever one is 2 over 2. 19 times 2 is 38. Okay, and then we already have 23 over 12 is in 12ths, so we can rewrite the whole thing as 38 over 12 minus 23 over 12. So we can just subtract the numerators. 38 minus 23 is 15 over 12, which reduces to what? 5 over 4. We can divide both sides by 3, or numerator and denominator by 3. 15 divided by 3 is 5, and 12 divided by 3 is 4. Okay, let's do one more example. I'll box that one in. And part C, 3 over 10 plus 7 over 12. Again, the first time we get to a common multiple, so we have 10, 20, 30, 40, 50, 60, 12, 24, 36, 48, 60. First time is 60, so 3 over 10 times something is equal to something in 60ths. So 10 times what is 60? Well, that's 6, so 6 over 6. 3 times 6 is 18. And then 7/12 needs to be multiplied by some common or clever 1 to get to 60ths. And 12 times what is 60? Well, it's 5. So 5 over 5, and 7 times 5 is 35. So now we can go back and take both of these and plug them in. So we get 18 over 60 plus 35 over 60. And 18 plus 35 is 53 over 60. And that does not reduce, so that is our final answer. Okay, we've talked about adding and subtracting fractions. We've talked about multiplying and dividing fractions. Let's talk about using fractions in algebra. Fractions in algebra. Example number 10. We want to determine whether a given number is a solution to the equation. And our equation is x minus 2 over 9x equal to 1. And our value for x is 1 2/7. Okay, so what we want to do is we want to, as in previous sections, we want to substitute in x everywhere we see an x. We'll substitute in 1 2/7 here and here. So we get 1 2/7 minus, and we'll put this in brackets, 2/9 times 1 2/7 is equal to 1. Okay, so we'll rewrite that as 1 2/7 minus, we'll do what's inside the brackets. We can rewrite 1 2/7 by multiplying the whole number times the denominator. 1 times 7 is 7 plus the numerator. 7 plus 2 is 9. And we're still checking to see if that's equal to 1. So when we multiply inside the brackets, we get that the 9s will cancel, so we're left with 2/7. So 1 2/7 minus, in brackets, 2/7 equal to 1. Well, 1 2/7 we found earlier is the same as 9/7, so we can change this one to 9/7 minus 2/7. Well, they have the same denominator. 9 minus 2 is 7 over 7 equal to 1. Well, 7 over 7 is just 1, so 1 equals 1. We have a true statement. So since we get a true statement, we find that x equal to 1 2/7 is a solution to the equation x minus 2/9 x equals to 1. That is the end of section 1.2, fractions in algebra. If you have any questions, please be sure to reach out to me. Good luck on your homework, and I'll see you in the next one.